Hello and welcome to another math video. Today we're looking at Algebra 2 Chapter 1 practice test. We are starting here with identifying and describing patterns. For number 1 we have our series of fractions. It looks like the numerator stays the same, and you might notice that we are multiplying the denominators by 3. So 2 times 3 is 6, 6 times 3 is 18, 8 times 3 is 54. And 54 times 3 is 162. So the next number in the pattern will be 1 over 162. Here we've got our figures from left to right. They want us to draw the next figure in the pattern. So notice the first figure has that corner, and the second one that's been cut off. Third one, of course, that's still cut off, and then they also cut this off. So it appears that we're rotating around cutting off corners. So if I try my best to sketch this out, we have those two corners out already, and then this corner would be the next one to go. So look like that. For number 3, a good way to start is to look and see what we're adding every time. So it appears that we're adding 3 segments each time. You can see that in the third figure. And if we even go back to the first one, if you think of it just as the initial part as being the 2 on the top, then you can see we're really adding 3 right away to the 2. So that can help you come up with an algebraic expression for the number of terms in there. Also, you might look at the figure number and have a process and an output, which would be the number of line segments. So for the first figure, we have 5. Second one, we have 8. And third one, we have 11. So we can see that we're adding 3 each time. So if we do like 3 times 3 here, 2 times 3 here, 1 times 3 there, and then what do we have to add in? We have to add 2. So that would get us to the 5, 8, and 11. So really the 1, 2, 3 in this column would be n, and then the 3 is what stays the same. So our expression could be 3 times n plus 2. So then if n is 27, like they ask for the 27th figure, then we would have 3 times 27 plus 2, so we're talking 83 for that one. Alright, and then looking at number 4, let's see, so one week you tell 2 of your friends a secret. The next week each of them tells 2 people the secret, and the next week each of those people tell 2 more people. So the way that breaks down is we have in the first week 2 new people know the secret. So we have weeks and we have new people that know the secret. So in the first week you tell 2 people. In the second week 4 new people know. In the third week 8 new people know, and so on. So the question, how many people find out the secret on the 10th week? Now I cheated a little bit. I read ahead to the question to kind of know how to organize my table. So looking just specifically at how many new people, or how many people find out the secret in the 10th week. So it appears that we are doubling every time. You could also think of this in a little bit different way in terms of, and then in the 4th week they don't say it, but 16. So really multiplying by 2 each time. Now you could continue that up until the 10th week, but here we really have 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. So in week 10 we would have 2 to the 10th power. That's how many people would find out in that week. And that turns out to be 1,024. Now we'll not get into the idea of whether this is even close to being a secret anymore or not. Alright, for number 5, we just want to come up with the algebraic expression that models the word phrase 5 times the difference of A and B. So we've got a difference of A and B, and that's being multiplied by 5. And so that's what that would look like. For number 6, we'll continue our modeling. We're talking sweaters, t-shirts, and pants. They define variables for us. Sweaters cost 25, and they're using S for that, so 25S would be in there. T-shirts cost 18, so 18T, and pants cost 17, so 17P. So this is the expression that models the total cost of clothes to buy. Again, we don't want to turn this into an equation, so just leave that as an expression. For number 7, we're just plugging a 6 in for x and a negative 4 in for y. So if we look at that, it'd be 3 times the negative 6 over 2 minus a negative 4 squared over 4. So we evaluate that, we end up with negative 18 over 2 minus 16 over 4. So that's negative 9 minus 4, so we're talking negative 13. Alright, for problem number 8, it says simplify combine like terms. So it looks like I'm going to have to distribute into my parentheses there, so I have an xy minus x squared plus a 4x plus a 4y. You can keep looking at that if you want, but it does not appear that there are any like terms, so there's really nothing we can do to combine like terms for that one. Alright, for number 9, we're solving the equation. I would begin by distributing the 9 into those parentheses, and we get 9t minus 114.75 plus 5t equals t plus 5.5. We do have some work to do on the left there, a 9t plus a 5t, that's a 14t minus the 114.75, and that equals the t plus 5.5. From here we're ready to start doing operations to both sides. I would decide to subtract the t from both sides, and so that will give me 13t. Actually, I'm just going to go ahead and put plus 114.75 there as well. So that ends up giving us 13t equals 120.25. So then we just divide by the 13. And that turns out to be a nice terminating decimal. We get exactly 9.25. So I'm okay with that because that is exact. Alright, number 10. 2 trains left the station at the same time, traveled in opposite directions. One traveled north, the other traveled south at twice the speed. After 4 hours, the trains were 600 miles apart. How fast was each train traveling? So, we know the time was 4 hours. We know the distance was 600 miles. We know the relationship between the two speeds. One was traveling at twice the speed. So if one is traveling at x, then the other would be traveling at 2x. So that's really the two different rates. We're adding them together because they're traveling in opposite directions. They were doing that for 4 hours, and that resulted in them being 600 miles apart. So we can combine the x's, and we can simplify the left side there by multiplying the 4 by 3x. That gives us 12x equals 600. And we can divide both sides of that equation by 12. From there we find out that x is 50. Now that doesn't actually answer the question. The question was how fast was each train traveling. So if x is 50, then one of the trains was traveling at 50 miles per hour. And the other was traveling at 100 miles per hour. And then looking at number 11, it's always, sometimes, or never true. So simplifying the left side, we get 8x plus 1. The right side, we get 8x plus 9. So we can certainly tell that something is up here because the 8x's match. We can see if we subtract 8x from both sides, we get 1 equals 9, which of course is not true. So that means that this would never be true. No matter what value you plug in there for x, you will not make that equation true. Alright, for number 12, we're looking at solving our formula for b. So lowercase b here is what we're looking at solving. And so one of the first things I would do would be to multiply both sides of the equation by 2. So if I do that, I get the 2 times the a, 2 times the 1/2 h, and then the b plus b. So 2 times a half, of course, is 1. So we just have the h times the b plus b then. Now we're trying to get into those parentheses, so probably the best way to do that is to get rid of the need for the parentheses by dividing by h on both sides. So we get 2a over h equals b plus b. And we're trying to solve for the small b, so subtract b from both sides of the equation. Now, not much we can do to make that look nice on the left. We're kind of just stuck with 2a over h minus the b. Whoops, I subtracted by the wrong b. I did the one I was trying to solve for. I'm just going to pretend that didn't happen. Subtract the capital B, and then we have the small b on the right by itself like we wanted to. So that's what that looks like. 2a over the h minus the capital B equals the small b. Alright, looking at number 13, we've got math scores so far of 68, 78, 90, and 91. The question, what score must you receive on the next test for you to achieve an average greater than 85? Well, so we've got some mystery score that we're going to average in. The mystery score will give us a total of 5 scores. So this is what the average of those 5 scores would look like. Looking for that average to be greater than 85. So we look at solving that inequality. The points so far add up to 327 points. Usually how I think of this is if I had an average of 85 on 5 tests, what would that total amount of points be? So, but really I'm multiplying both sides by 5 here, and we get 425 points. So the x plus 327 is greater than 425, and then all we do is subtract the 327 from both sides to find out that x has to be greater than 98. And so, again, to answer the question, what score must you receive on the next test for you to achieve an average greater than 85? So you need at least a 99. Again, 98, so the score has to be greater than 98. Well, again, I guess I don't know if we're going to do half points or anything like that, so maybe at least a 99. Not the best answer there. Maybe we'll say over the 98. So 98 would not get the job done, so you'd have to have over 98. Alright, next we've got an always, sometimes, or never problem for an inequality. It's going to be just go through solving with our regular process, so distributing the negative 2 on the left side. So we get negative 6x minus 14 is greater than negative 6x plus 6. So again, we know something is up because of the 6x's or negative 6x's matching. So it's just a matter of determining what it is. So again, the key here is just whether the statement is true or false. The statement is negative 14 is greater than 6, which is false. This false statement at the end means that that will never be true. Again, no matter what value you plug in for x, that inequality will never be true. For number 15, solving the compound inequality and graph that solution. So we will really just solve those two separately and then put that together on the graph. So I'll start with the 9x plus 11 is greater than or equal to negative 7. So I'll start by subtracting the 11. So we get 9x greater than or equal to negative 18. And then divide by the 9. We get x is greater than or equal to negative 2. And do the same thing for the other one. So we'll add 6. Gives us 3x is less than or equal to 15. Divide by 3. We get x is less than or equal to 5. So this is fine for having solved that inequality. Again, notice the use of and like they have here. The graph, again, you don't have to do anything too fancy with that graph. Put a negative 2 here and a 5 there. They both have the equal to, so we'll use closed points. So the numbers that are greater than or equal to negative 2 and less than or equal to 5 are just these. Again, one thing we should not do is we shouldn't have just an arrow going this way and an arrow going that way. The arrows imply that those continue on, so we want just a segment in between the negative 2 and the 5, not the arrows. Same sort of thing for number 16, although this is an OR compound inequality. But we still just solve those separately. So we'll start by adding the 6 over here. Be careful when you're dealing with adding to a negative. So we get negative 35 when we do that. That'll work out nicely because then when we divide by the 7, we get x is less than negative 5. Same sort of thing here, subtract the 14 from both sides. Gives us 4x is greater than negative 12. And that works out nicely as well. We just get x is greater than negative 3. So negative 3 would actually be over here, negative 5 over there. These do not have the equal to, so we would use open circles. We're looking at less than negative 5 and greater than negative 3, so it would look like that. And as far as solving it, as long as I throw the OR in there, then that's what that would look like. Alright, next we'll take a look at solving this absolute value equation. Our first objective is really to isolate that absolute value. So we'll start by subtracting the 3, that's a 3 really, from both sides of the equation. That gives us 4 times the absolute value equals 20. Again, that will work out nicely because next we need to divide by the 4. Which finally gets us to having that absolute value isolated and equal to 5. Now here, when we have an absolute value equals a positive number, guarantee we will get two solutions that work. So we set up our two equations. We'll have 4x minus 1 equals negative 5, and really or 4x minus 1 equals positive 5. we go through solving those two equations. We get 4x equals negative 4. Divide by the 4, we get x equals negative 1. So there's one of these solutions. And then the other one, we go through the same process, add 1. We get 4x equals 6, divide by 4. 6/4 reduces down, so do not leave that as 6/4. 1.5 is okay because it's exact. You don't need both, just one or the other. And again, I'm not worried about it, but again, technically there's an or there. So either -1 or 3/2. So those are both two solutions that work for x. And again, I know that they are not extraneous because once we got it isolated down, and really it's at this point here, we can see the absolute value equals a positive, so we're guaranteed two solutions. Number 18 is similar, but there are some important differences. One of the first things we need to do is isolate this absolute value. It will work out okay for us here that we can divide by 2, largely because the 2x minus 2, or 2x plus 2, sorry, is divisible by the 1. So again, the 2x plus 2, you can take a 2 out of that. You get x plus 1. If that's over 2, then those cancel out. So that's how we get just x plus 1 on the right side. Now, at this point, they do mention extraneous solutions, and we need to worry about that because x plus 1 is positive for some values of x, and x plus 1 is negative for other values of x. So we don't know for sure until we find our solutions whether they are going to actually work in the original or not. We still go through our same process. We'll set up 6 minus 4x equals the opposite of x plus 1. And we will set up 6 minus 4x equals x plus 1. So over on the left here, 6 minus 4x equals negative x minus 1. With that, I would decide to add the 4x. And if I'm doing that, I'm also going to go ahead and add the 1 right now. So we get 7 equals 3x. So it appears then if we divide by 3, x would equal 3/7. Again, so we think that is a solution. At this point, we'll talk about checking that in just a minute. Solving our other equation, in this case, I would add the 4x. So we get 6 equals 5x plus 1. We can subtract the 1. Hey, look at that, 5 equals 5x. So divide by the 5, and we get x equals 1. Let's see. So again, we should check our solution in the original equation. However, a little shortcut for you, if you know how to use this one, that's great. Again, the problem happens if we have an absolute value equal to a negative. So the question is x plus 1 positive or negative? Well, if we look at it using the two x values that we came up with for our solutions, you plug a 1 in here, you get 1 plus 1, which is 2. You plug 3/7 in here, you get 10/7, which is positive. So again, unless we made some other mistake, then 3/7 and 1 are the solutions. They can't be extraneous solutions. And then that brings us to the last question, solving the inequality. We need to first isolate that absolute value. So we can begin by adding 3 to both sides of that inequality. It gives us the absolute value of x plus 2 is greater than or equal to 13. Now there are a few different ways that you can do this. Again, the simplest one, I believe, is just set up or change this to an equation, solve for your endpoints, and then you can determine where the inequality would be. So the equation being x plus 2 equals 13, absolute value of x plus 2 I should say. So we solve both for the negative 13 and for the positive 13. And so we just solve those two equations separately. We get x equals negative 15 and x equals 11. So on our graph, put a point at negative 15 and a point at 11. The inequality had equal to, so we'll do closed points. And then we need to determine, again, where this is true. I tend to like to test 0 and see if that makes the inequality true or not. So if I test 0 in that absolute value inequality, I get the absolute value of 0 plus 2 minus the 3 is greater than or equal to 10. So absolute value of 2 minus 3 is greater than or equal to 10. Well, that's not going to work out. So we get 2 minus 3 greater than or equal to 10. So negative 1 is greater than or equal to 10. So this is clearly false. So 0 being false, that means that the graph would go out and away from that. And so then the solution for the inequality actually ends up being x is less than or equal to negative 15, or x is greater than or equal to 11. And again, I cannot emphasize enough, you really need the or there, otherwise it's not the same thing. So thank you for watching. Hopefully this helped.